This is the first video in a unit about chemical kinetics, and chemical kinetics are how fast a reaction occurs. So we're looking at rates. We have to understand just what a rate of reaction is before we can get into any sort of calculations and what affects these rates. So first, just a rate in general is something related to speed or how fast. It's a per unit time. So a rate of reaction is the speed at which reactants are used up or products are formed. So you can look at this either way. You can look at this as being reactants getting used or products being formed, right? Because products are being formed because reactants are being used. So rates are measured in per unit time. So we've got this 1 over seconds to the seconds to the minus 1. The top value, the numerator, will depend on kind of what you're measuring. Like it very well could be concentration per your unit time, so concentration per second. And you may recall that these units, just something per second, this is a frequency. And we talked about this previously when we talked about waves. And we would calculate their frequency related to the wavelength and the speed if they're traveling at the speed of light. So lots of times when we have rates, we're going to talk about them in terms of concentration per second. So the units for that would be this. This is how IB prefers to write them. You might prefer to write them like this because it's concentration, moles per decimeter cubed, per second. You might prefer to write them as actually moles per decimeter cubed per second. So like this. This is the simplified way, which comes from this first way that I drew it. If you want to do the math here, to get the seconds into the numerator, you would multiply by the reciprocal. So you should be able to see how you get that. So IB prefers this first way. I prefer to do it that way. I circled in blue because that is going to help us when we get to some of our calculations, and even just to understand how it's a change in concentration per time unit. So in terms of like equation-wise, what are we actually doing? Well, we talked about up above how it is a change in the speed at which reactions are used up or products are formed. So you'll see these formulas right here. So change, remember, is that delta right here. And P is for products, R is for reactants. Notice the brackets, just a quick reminder, that bracket means concentration, if you remember that. So that stands for moles per decimeter cubed. And notice that the R is a negative value. That's because our R is decreasing, right, being used up. And our product is increasing over a change in time. So we've got that delta T, T for time. All right, so when we graph these and we talk about these graphically, or we analyze them that way, when we plot them, it's going to be a plot of concentration versus time. And this is going to give us a curve. And I'll show you more of these in a second. But what we can do is with this curve is we can draw a tangent line. And you may have hopefully talked about tangent lines in math, especially if you're in calculus. But if you draw a tangent line to any point on that curve, at that particular time, you get what's called an instantaneous rate. So like, what is the rate at t equals however many seconds? A tangent line at t equals 0, right, the very beginning, so nothing's actually happened yet, gives you your initial rate, so the starting speed. So you've got these two graphs in your notes packet. I know they're not really clear, but they're from your textbook. So make sure you maybe open your textbook to look at them a little more clearly. But looking at this first one, you've got the tangent line right here, right? This one in black. Okay, so notice, sorry, not a tangent line. Let me say that again. You have the curve for the rate here in black. And if I want to find the tangent line at t equals 120 seconds, that's what this red one is. That's this one right here. That tells me the rate at that particular moment, just instantaneous, just at one point in time. Now, if I did t equals 0, that would be up here. I'll do that in blue. That would be a tangent line right here. And then notice, that would be my initial rate. But notice as I keep drawing tangent lines, do you see how they keep getting flatter and flatter? And what you should note is that as the slope of the tangent line gets closer to 0, right? So like this is a 0 slope. Oops. Okay, this would be a flat would be a zero slope. The rate slows down. So as time goes forward in this first graph, you can see all these blue tangent lines get flatter and flatter and flatter because the rate's slowing down because you're using up your reactants that are turning into products. So there won't be as much product produced. The second one is just another graph of a different reaction. So you can see this again, and you can see the red line up here. The red one up here is the initial. So it's fastest at the beginning, and then it flattens out as you go further in. Okay, so you do not have to understand calculus or know how to do calculus to do this, but you should understand what a tangent line is, and understanding some of these concepts will help you understand rates going forward.